So, the next topic is about the application of Pascal's law, the hydraulic lift, as we already discussed. So, hydraulic lift works on the principle of Pascal's law. So, hydraulic lift is a lift which makes the use of the fluid. For example, hydraulic lift that are used in car service station to lift the cars. And also the principle inside the hydraulic lift, there are two platforms. One has small area, another one has large area. So it is a tube-like structure which is filled with uniform fluid. There are two pistons, P1 and P2, which are attached at bottom of the tube. So cross-sectional area of P1 is given as A1 and P2 is given as A2. If we apply force F1 on P1, pressure gets exerted, and according to Pascal's law, the pressure gets transmitted in all directions and the same pressure gets exerted on the other hand. As a result, the piston P2 moves upwards. The advantage of using hydraulic lift is that applying small force on the small area, we are able to generate larger force. So mathematically, we can conclude that F2 is equal to P A2, where F2 is the resultant force and A2 is the area of cross section. And we can just conclude with the formula that P1 is equal to P2. So F1 by A1 is equal to F2 by A2. So we can determine the formula of F2 is equal to F1 by A1 into A2. So now also discussing about the hydraulic brakes. So hydraulic brakes also works under the principle of Pascal's law. So according to this law, wherever the pressure is applied on a fluid, it transforms uniformly in all directions. Therefore, when we apply force on a small piston, pressure gets created which is transmitted through the fluid through a larger piston. So as a result, larger force will be developed and uniform brakings applied on all four wheels. As the braking force is generated due to hydraulic pressure, they are known as hydraulic brakes. Liquids are used instead of gases, as liquids are incompressible. Okay, and so regarding the construction part, so just we'll move on it. The fluid in the hydraulic brake is known as brake fluid. It consists of a master cylinder, 4 wheel cylinders, pipes carrying brake fluid. Okay, carrying brake fluid from master cylinder to all the wheel cylinders. So master cylinder consists of a piston which is connected to a pedal through connecting rod. So the wheel cylinder consists of 2 pistons which fluid is filled. Each wheel brake system consists of a cylinder brake drum. This drum is mounted on the inner side of the wheel. The drum revolves with a wheel. 2 brake shoes which are mounted inside the drum remains stationary. So speaking about the working of this hydraulic brake, so when you press the brake pedal, piston in the master cylinder forces the brake fluid through the linkage. So as a result, pressure increases and gets transmitted to all pipes to all wheel cylinders according to Pascal's law. So the construction should be kept in mind. So the fluid which is filled in brake system is called as brake fluid. It has master cylinder. So it has master cylinder and 4 wheel cylinders which carries pipes, okay, which is having pipes, and also which carries brake fluid from the master cylinder to the wheel cylinders. Okay, from master cylinders to wheel cylinders, it carries the fluid. So the master cylinder is having a piston which is connected to a pedal. Okay, and this wheel cylinder consists of 2 pistons. Okay, so what will the master cylinder do? Master cylinder will, so what will happen actually? So each wheel brake consists of a cylinder brake drum. So this drum is mounted on the inner side of the wheel. So the drum revolves with the wheel. So when you press the brake pedal which is there in the master tube, so the piston in the master cylinder forces the brake fluid through the linkage. So as a result, what will happen? The pressure is created and it is transmitted to all pipes of the wheel cylinders according to the Pascal's law. So this is the working of hydraulic brakes, and also from the conclusion we can clearly understand that here in hydraulic lift they are using 2 levers. So one lever is of small area of cross section, another lever is of large area of cross section. So when the force is applied on a smaller piston, what happens? The pressure will be created in the liquid, okay, in which the fluid will transmit the pressure in all directions so that it creates the larger force. Okay, so that it creates a larger force and it carries heavy loads, so that we can conclude that P1 is equal to P2. As we already told, pressure is inversely proportional to velocity and pressure is inversely proportional to area as well. So when the area is less, the pressure will be more and the velocity will be high. Okay, when the area is more, the pressure will be less, so the velocity will be high. Okay, so in this this is a clear idea about the hydraulic lift and the hydraulic brake.